All right, we're going to look at how to find the angle between two vectors. So what we can do, we can use the dot product and the law of cosines together to come up with a formula for the angle between two vectors. Now, originally I'd planned on doing that, deriving it for you here, but I decided I'm going to put that in a separate video. So for now, let's look at the formula and let's use it on a few things. Then we'll come back and see where it comes from later. So the angle between two non-zero vectors in Rn is given by this. Cosine of theta is u dot v over the length of u times the length of v. So let's do a couple of examples. Find the angle between these two vectors here, 11, 1 and negative 2, 5. Okay, first up, let's see their dot product. I'm just going to write this out over here. The dot product is going to be 11 times negative 2, so negative 22 plus 5. So their dot product is negative 17. And the lengths, I'm just going to work out below each of these. The length of 11, 1, that's going to be the square root of 121 plus 1. And the length of this one is going to be square root of 29. So cosine of theta is going to be negative 17, the dot product, over the product of their lengths. Let's see, where did my calculator go? Here it is. All right, so we're going to get some ugly numbers here. On top, I've got negative 17. On the bottom, I've got the square root of 122 times 29. When I put that in my calculator, I'm actually putting it in as a single square root because, you know, properties of radicals, we can multiply them together like that. So this gives me an answer of, well, I shouldn't say an answer. It gives me cosine is negative 0.028, etc. I'm going to put a few more, 2858, and so on. But I want the angle here. And unlike in calculus, I want the angle in degrees here. So first, let me figure out how to put my calculator into degree mode. All right, I'm in degree mode, and I'm not going to delete any of this. I'm going to keep it in here, and I'm going to do arc cosine of my answer. And it gives me an answer of 106.6 degrees. Theta is approximately 106.6 degrees. And if we were to graph this, we could graph it really carefully, but I'm not going to. 11, 1 is going to stick out over here. And negative 2, 5 is going to stick out up here. And so just drawing it roughly to scale like this angle, it does look a little bit bigger than 90 degrees. So it works out. All right, let's do another one. Find the angle between these two vectors. All right, so the dot product of these guys is going to be 0 plus 0 plus 3. And the length of this is going to be, the squares here are 0, 1, and 9. So that thing is square root of 10 length, and this one has a length of square root of 26. So cosine theta is going to be 3 over root 10 times root 26. So 3 divided by root 10 root 26. When I put that into my calculator, I get cosine theta is 0.18605 and so on. And my theta, I'm getting this by taking the inverse cosine, or the arc cosine, of that number. So when I do that, I get arc cosine of that. It gives me an angle of 79.277. $5. For some reason, I wrote that one out to a whole bunch of decimal places. So that's it. All right. On a test or on a graded problem, I would specify how many decimal places to go to. But typically on these things, you wind up getting something that's a decimal number of. You rarely get a nice number out of these because there are only a handful of angles that, well, there are only handfuls full of nice angles that have nice cosine values.